Welcome to this Informix Tech Talk on the new YouTube channel. I'm Ben Thompson. I'm a DBA. I've been a DBA for nearly 20 years now in one form or another. I'm now principal DBA at Sky Betting and Gaming. We run Informix as our primary database, so we've got quite a lot of large systems. So I'm going to share some of the experiences that we've learned on those with you today. This is a pre-recorded presentation, which means that I'm recording this on Monday and you'll be watching it on Thursday, and I'll be in the channel while you're watching it to answer questions. So please mute your line. Background sounds will distract everybody. And if you want to ask me questions, just use the chat button. So as I said earlier, I'm Ben Thompson, DBA, technical lead. I also have a blog I write, increasingly occasionally, which is called Informed Mix. So I'm going to be talking today about large table operations. So they're the sort of thing you do during maintenance of the system, and typically operations that would take a long time. They might be, this definition is a bit woolly perhaps, but a large table operation might be one that's perhaps too big to fail and that you haven't really got time to allow it to roll back. You might find that there's pressure from your business to keep the downtime low. You might be using site reliability engineering in your business where there is a cost for the downtime. And it may also be difficult to test. It really depends on what testing systems you have where you are. I'm going to perhaps show you some ways you could test things perhaps more simply on smaller systems to make sure they're going to work if you haven't got a full scale test system. And sometimes, because operations are very large, the most obvious way of doing it might not be the best way because that might simply just take too long. Okay. I'm going to go through the sort of thing that might go wrong during a large table operation and how you can prevent some of those things. Some of them may be obvious. So long transaction is one that you definitely don't want to happen. So making sure you have enough logical logs and that those logs are large enough so that your backup system can cope, because sometimes backup systems are more efficient with larger logs. And you also want to check your watermarks for rollbacks. So you've got the first watermark where your transaction will begin to roll back, and you've got the second watermark where it would exclusively take over the system. So you want to make sure you don't hit those. The other thing is you don't want it to take too long. I think a long time ago I might have pressed Control-C during a large table operation, and I found that the rollback took a very long time, and that is particularly true on versions prior to 12.10, where in 12.10 there were some improvements to the speed of rollbacks. You might also find your lock table gets very large. Even if that doesn't get so large that you run out of locks, it may slow down your system a bit. Large lock table can make your system run more slowly. A lot of these large table operations involve rebuilding indexes implicitly, if not explicitly, and so you've got to make sure you've got enough sort space as well. You may also find with index builds, if you've got RSS replication or HDR replication, that you've got things like transmitting the index to the secondary server or index page logging to worry about. So that can slow you down as well. And you may also find that you get replication lag or log backup lag. Again, there may be things you might want to watch for. So I've got a fairly short list here of some common large table operations that you might want to do. So building an index is one. Can take longer than you think. You may also find with systems growing large that you might need to do some table partitioning or repartitioning. It's fair to avoid the no more pages error. That's something I'm going to cover here. And you may also just want to copy data around your system. Okay. So here are some things in the toolbox that we've got. I'm going to go through some of these. So we've got various things to do with alter table, and we've got more recently in 12.10 XC13 onwards, we've got loopback replication. And I'm going to show you also how to use high performance loader, which is a bit old fashioned, but I kind of like it, and I think it's still very useful on systems today. Okay, so going through some of the alter table stuff then. The easiest one, which I'm going to show you, is if you've got a table and it's running out of pages, you might want to just convert it to round robin replication, or even in this example where you might already be using round robin replication, the easiest thing is just to add more partitions. So in a table that's round robin, new data gets striped across the partitions you've got. So I've just got a simple drawing here of two partitions, a table with two partitions. And you can add new partitions. So you can add some new ones here. The new ones will, of course, be empty. Now, what used to happen, or still does happen if you haven't changed a setting, or you've got an older version of Informix, is that when you add new partitions, data continues to get striped across those partitions evenly. So you're still filling up the partitions that are nearly full. You're just doing it half as quickly if you've added two more, like in my example. So you can switch on auto locate. Auto locate is an on-config parameter that's in 1210xc3 onwards, and that means that the engine will write data to the partitions that have the least space. So that one was a little bit of a cheat because it wasn't really a large table operation, but it was just a simple means of avoiding some of the operations I'm going to show you later on. Now, create index, there's no magic here. I'm not showing you anything new here. I'm just showing this to say things you need to be aware of when you do some of the other operations, that indexes may get rebuilt. And you need to basically follow the same guidelines as you would for building an index efficiently when doing some of these other operations. So you might want to increase parallelism with psort nprox. I think later versions of the engine do give more threads than they used to by default, but you still might wish to set that. You need to make sure you've got enough temp space. If you don't, you'll get a partial index build, which will work, probably will work, but maybe slower. And you can do that either by just simply having enough temp space, or you can use a file system with psort dbtemp. If you've got Enterprise Edition, you can set PDQ priority. PDQ definitely speeds up index builds, and I think you'd want to use it if you can. You need to be aware of the requirements of HDR and RSS. Index page logging can be slow. It can take a long time. You can maybe switch it off. It depends on your system. If you need it for RSS replication, you probably can't. So you just need to be aware that your index build is going to take longer. So I'm going to show you here alter fragments on table INIT. I don't particularly recommend this method, but it is one of the easiest. So you can do quite a few things with it with tables. You can move a table from one DB space to another. You can use it to partition a table. So that's supposed to be a robin. I don't think robins have quite as long tails as that, but it was the best graphic I could find. So here we are. I'm changing a single table to round robin. You can also use it to change a round robin table or any other type of partitioning back to a standard table. And you can also change from one partitioning type to another. So that's my graphic for expression-based partitioning, where we've got different categories perhaps, or maybe it might be list-based, but it's actually meant to be expression-based. Okay. As I say, this is all good if you've got time to do it. It's very easy. It's just a single statement that you can write. It preserves all aspects of your logical schema, so there's no cleanup to do afterwards. It can be slow. It is, especially if you've got many indexes. If you're moving a table, all the indexes that reference that table have to also be updated. So if you've got a lot of indexes on a table, the engine is doing more work than you might think. So, and it perhaps is the one where you're most likely to get a long transaction. It is just one long transaction from the start to the finish, and there is that temptation to hit Control-C. So, auto fragment on table and init, easiest, but perhaps not the best way of doing something. Okay, We can also use alter fragment on table attach, and this is more flexible than you might think. So I used to think this was just perhaps for warehouse operations where you might have a table with lots of data in it, and you would you perhaps want to have a rolling window, so you would detach data that's over, say, 12 months old, move it to another system perhaps, but you can actually use it as well to maintain your system and do sort of general DBA work. So there's a few things you can do with it. You can also, there's also an auto fragment on index, but I'm just covering the table part. So you can join two non-partitioned tables together to make a partition table. So that's one thing you can do. And in this example, round robin, there are other examples. So, by the way, I think on partitioning, I had a read of Carson Doe's 1410 document. And I'd like someone to correct me if I'm wrong on this, but I think you can use round robin partitioning with workgroup addition, but not the other types, from the way I read it, because it talks about using logical expressions to eliminate data, which round robin doesn't do. Okay, so you can also use it to create an expression-based table, or list-based, or that's my range-based. That's what that graphic is. Perhaps not the best graphics, but so we've got round robin, expression, list, range partitioning. Okay, so we can also join a non-partition table to a partition table. That's another thing we can do. So we can make it a three-way round robin table. We can have an extra expression. We can have a longer list, or we can have a bigger range. Now, as I said earlier, indexes might be a problem. So when you're attaching data to a table, it's easy just to think about the data and not necessarily think too much about the indexes. So when it's easier to get an attach, or even a detach for that matter, to work without the data having to move, but less easy for the index. So the goal of this, or which may not always be achievable, is to be able to do this operation without having to actually move any of the data on the disk and just update the table definitions, the table headers. And then if you can do that, it'll be very, very fast. But it's difficult to do that, or impossible to do that in some situations. So we've got to think about the indexes as well. So this just shows we've got a B-tree index. It's pointing to a partition table. It doesn't really matter what sort of partition table it is. And if we drop one of the partitions, then we've got to update all the index to remove the references to anything that's in that partition. Furthermore, you've also got to run update statistics. Now, if you've got auto stat mode set, that will happen automatically. And what that means is that you can't drop a second partition immediately. You sometimes have to wait for update statistics to end. So you may want to switch off auto stat mode if you're doing this type of thing. Now, as I mentioned earlier, it is possible to do an attach without any movement on the data or the indexes, but to do that, you do have to meet some quite strict conditions. So this is an example here. There's actually two examples in one, because I've got an example for both expression-based and range-based partitioning that does this. So the key thing here is, if you look at my original table, it is stored in my DB space 1, and so of all my indexes. So, and also what this means is that the indexes can effectively follow in the table. Now, what we can't have here is a second unique index that starts on a different key. That if you've got that, this won't work. Now, so I've got that as my initial starting condition, and I'm creating a second table. I'm calling it T expression. So that's aimed at doing expression-based partitioning. That was change it to. And I'm just creating that table a slightly cheaty way by doing a create table I select star from, and that just creates a table with the same schema with a different name. It won't have any indexes, on it, but we can add those in a moment. And then we can do an alter fragment on that table and init it, but because this table's empty, this will be very quick. We can change it to expression-based partitioning. And we can then index it, which is the next part. And then we can attach the original table to our empty expression-based table, and it will attach, and the data will not move, and the indexes will not have to be changed either. So that's in this particular example. So this is actually in the Informix manual. What is not in the Informix manual is doing it for range-based partitioning. So I think this is a recent enhancement because we did raise a case about this not working. So it might be that this doesn't work unless you get 1210 XC15 or 1410 FC6 when they come out. But you will at least in the future be able to do that for range-based partitioning. Okay. Detach is pretty similar to attach. You need indexes to follow the table so that when you split the tables out, the indexes don't have to move. Okay, so you might want to test this. This is actually quite straightforward to test, really. If you can't test it on a full-scale system, so I guess if you test it on a full-scale system, you would just go with, I've done this operation and it only took, say, 5 seconds, so therefore I don't think any data movement occurred. If you can't test it on a full-scale system, and in fact I think this way is better anyway, you can use the extents report from onCheck, which is onCheck minus PE, to have a look at the extents for the tables. So here I'm attaching, again, T original to my expression-based table, and I have a look at the extents, and I can see here that the extents are all the same for both the indexes on the tables before and after. Now the names have changed because the table name has changed, but the extents are the same. So that shows me that when I do this operation, it's going to work very, very quickly. Okay. I don't know how we're doing for time on the talk, but I think most of the talk I'm going to spend talking about loopback replication anyway. So loopback replication is something that's quite new or relatively new. I think it only came in 1210XC11 or maybe 13. I can't remember. I do actually have it in my notes somewhere. What it is essentially is enterprise replication, but where the source and the target, and that's the language I'm going to use here, source for the source table and target for where we're replicating to, are the same instance, or they're tables in the same instance. Previously, you had to do enterprise replication between 2 separate instances. So you can see that you could use this to replicate a table to a copy of itself. And what we're trying to do here is, rather than do some of these large table operations, we're going to just create a copy of the new table, and we're going to slowly drip data into it so that we've got a copy of it, and then at some point we'll just quickly switch them around. And that means that even though that would take longer than doing the operation with alter table, the actual amount of downtime involved is much, much less. So your business will probably be happy with that. And in some ways, this is perhaps easier on you as well. Awesome. So loopback replication is something that we have sort of set up on our servers all the time. So there are some preparation steps that you only need to do once. And they are essentially some on-config tweaks and also some DB spaces and SB spaces that you need for enterprise replication. So you need to do some tuning on this, which I'll cover in a moment. And this might be on the next slide. So I was going to go over now the general approach. And some of this is actually very similar to the CDR migrate feature that there is, but this is just for a single table rather than the whole database. So the first thing to say about loopback replication is once you switched it on, it doesn't actually do anything to copy your table. It's just taking new transactions and it's trying to apply them on the target. So that's new transactions from the source, apply them on the target. So we start by creating an empty copy of the table. We want that table to have all the modifications that we want to do. So if it's going to be partitioned differently, it's going to have different indexes on it, different constraints. We can do all those things. Now, my approach at the moment is to bulk copy the data, and I'll go through some means of doing that as well. And then we can create the indexes and primary keys. We can actually do that as well before bulk copying the data if you prefer. It doesn't really matter too much. And then we're going to start with replicates. So replicate is an enterprise replication term for two tables that are being replicated between each other. And if you think about that, so we've loaded the data. We could actually load the data while the system is online. We could then start the replica, which means we start applying transactions. But because there might be some gaps in when replication was running and the bulk copy perhaps wasn't fully consistent, we then need to check the table for consistencies and repair them. So I'll go through how to do that as well. So this stuff is all in the Informix manual. We need to create DB spaces, 2 DB spaces and a smart blob space for enterprise replication. We need to go through and do some work on SQL hosts to create ER groups and also a pseudo loopback listener. And we put those new listeners, a new listener in DB server aliases. We then need to do some ER server definitions with CDR defined server. There'll be 2 lines for that. And pretty much then we're good to go. So I've got some performance recommendations here. So some of these are interesting because they're based on our experience and they do differ from the Informix manual slightly in a few cases. So I was going to emphasize that I do know a little bit about this, but I don't think I'm supposed to talk about it too much. But it has been in a published roadmap that ER is getting an overhaul in either 14 to X26 or X27. And there are quite a few performance improvements and optimizations that are going into it, which invalidates some of the tuning advice I'm about to give. So this tuning advice here is for the existing version, they're on 12.10 or 14.10 up to whenever the enterprise replication improvements get released. So the first one is CDR valve threads, which is these are all on config parameters. So the Informix manual actually has a note in it, which is quite bold and it's got a box around it, and it says you must have at least one valve thread per CPU VP. We found this was not a good idea. What tends to happen is the valve threads block each other quite a lot on a mutex and can eat up quite a lot of CPU. And because they're blocking on a mutex, they're not actually doing any useful work. So if you've got a large system in particular, you probably don't want to follow this recommendation. We found that 10 valve threads is sufficient for and certainly for the type of thing I'm showing you here, which is just to replicate one table. 10 valve threads is fine. You can configure up to 4 gigabytes of memory for CDR. The recommendation from IBM support, I haven't done this testing myself, it's from IBM support, is to use 64s or 128 megs as sort of an optimum value. You may run into some problems if you set larger values, even if you've got quite a lot of memory in your server. Now, you don't have to use ATS and RIS. So ATS and RIS are when you apply a change on your targets, that's your table you're replicating to, and for some reason that change cannot be fully applied. So it might be the example here where you're trying to update a row that was inserted earlier, but because when you just started replication, you don't have that row. You missed the insert where that happened. So instead of just producing an ATS file to say I could not update this row, you can get it to automatically change that row into an insert. So you can do that by setting 3 there. Now you can have lots of different values and you can kind of separate them. So you may want to look at documentation for that to see what's suitable for you. But for this particular use case of loopback replication, I'd recommend putting at least 3 in there. The last recommendation I've got is about the size of the smart blob space. So the smart blob space is used for things like storing the send queue. So what actually happens with enterprise replication is it's asynchronous and it's reading the log. And there's what's called a log snoopy position, which is where the log reader that's reading the log is. And it's usually behind where you are or your server is, the point, real time. And when it finds an update on a table that's defined as a replicate, it will put something in what's called the send queue. So the send queue is just effectively messages that say, do this replication thing. And with normal ER, where you've got two servers, that would go over the network to the receive queue on the other side. On loopback replication, the send queue and the receive queue are both on the same server. What can happen is that the send queue can get very large, and when it does get large, if it particularly gets larger than the qmem parameter, it will start to spool those messages to this CDR queue data SB space. So you need to think about how large that needs to be. Now, it can need to be really quite large in some situations. I mean, it is just as SB space. You can make it bigger if you need to. I don't think it works with automatic expansion via storage pools for CDR, so you do need to do it manually. But I'd recommend, if you're doing a large loopback job on a table that's, say, got hundreds of millions of rows, or even up to 1 billion rows, you need this smart blob space to be quite large. And so I'm putting 100 gigabytes there as sort of a figure, but your mileage may vary. But if you've just got a few gig, that might not be enough for these large jobs. Okay, so I'm going to talk about the bulk load phase now. There are quite a few ways to do bulk loads. I mean, you could just write a stored procedure to do it, do some sort of insert into select thing. That might work, particularly if you can exclusively lock the tables. But again, we're trying to do this with low downtime. So maybe you can exclusively lock the target table because you won't be using that yet, I guess. I find that for this kind of thing, high performance load is very easy. I like it. It's old fashioned, but it does still work. It's still in the engine. I use the command line to do it. That there used to be, or maybe there still is, a rather clunky X Windows based GUI util for it. If anyone remembers that, I've tried to forget about it. It's not very good, but you can do this on the command line. So a few commands there. So that's just all that's doing is we're creating a unload job. It unloads to what's called a named pipe. So I'm afraid this would only work on Linux or Unix-based systems, this particular method. And then we've got a job which is loading data from the pipe. And so we've just literally got two commands there, one to set up the unload job, one to set up the load job, and then two commands to then run those jobs. So those two commands, that they won't return control back to you until the jobs have finished. The other thing I like about HPL is I don't have to worry about commits too much because it's just a simple parameter that I can pass. So I've passed 200,000 as my commit interval. Perhaps that's a little high. There's diminishing returns for huge commits. As long as you've sort of got about 10,000 plus, or maybe around 50,000, you won't see much benefit from going to 200,000. You don't want to be doing like committing every row either. So HPL, I think it's nice and easy, particularly for something like this. And I've given you a copy and paste that you can use if you're not familiar with it. If you do mess up HPL, all you need to do is drop the onpload database. So the onpload database will appear when you run your first HPL command. It will just create that for you in the background. So it's quite easy to get out of a mess in HPL, basically. Okay, so that was my bulk load, and now I need to define my replication. So this is really, the first two lines really are straight out of the manual. They're just how to define loopback replication on a server. So here I'm using two groups I've created earlier in the SQL hosts, G my instance ER server and G my instance loopback. So they're SQL host groups, as I say. I have set up ATS and RIS DERs to capture failed transactions that don't apply through loopback. You may not be interested in those. You don't have to use them. And then finally, I've got my replicate. So I'm defining one single replicate. There are some commands there. You can actually do quite a lot of stuff with ER or loopback if you want to. You don't have to replicate every column. You don't have to replicate every row, so you can do that by adjusting the select statement that's there. But here we're saying that we've got a master, using the term master here, I'm using the term source, but we're saying that the source is always right, basically. So if there's any difference between the source and the target, the source wins. And lastly, we need to start that replicate as well. So CDR define won't actually start the replicate, so you just do CDR start REPL. No, is that right? I'll have a look at that in a minute, but you can look that up in the manual. I think it's CDR start, CDR stop. Okay. So then you're going to go and check repair the replicate. Now, I've got a few things to say about check and repair. So check and repair, what it does is it will read down your source table and it will do a select of any columns in the primary key, and then all the other columns it will select as well, but it will run a checksum on them. And it will do that on the target as well. So the target's the same server, just a different table. So and that will be ordered by, and it will just run down each of them, and it will make sure they're the same. And if they're not, it puts a message on the send queue to replicate the table. So replicate that change from the source to the target. Now, this is a little bit slow, and so this method perhaps isn't suitable for when you've got a high volume of change on the table, because this simply just won't keep up. It's just a single SQL session or thread, basically just running down the table, and it's a little bit slow because of the checksumming. Now, you can use something called a REPL check column. This is documented in the manual. This is a column that you add to, it's actually a hidden column that you add to the table. You have to add it to both the source and the target. There's no point whatsoever if you just add it to one of them. And it's essentially a pre-calculated checksum that's there. And furthermore, you have to index it as well. So your index you have to create is your existing primary key columns plus the REPL check column as the last column in the index. And if you do that on both sides, and you've got the index there, CDR check is much, much, much faster, probably around 100 times faster at least. Now, the problem with this thing is to do that, you've got to create that unique index, and you've got to add that REPL check column. Adding the REPL check column on a big table is a single transaction. It's very difficult to do on a large table. And really, if you're going to do that, you might as well have done whatever operation you're trying to avoid anyway. So probably if you're doing this, you're not going to be able to do it. You're going to find it impractical. So you're going to be running CDR check the slow way. Now, it's important to give your check a name. And I think I do that here. Yes, -- name. Now, if you don't give it a name, I don't know if this is a bug or not, but you then can't check its progress. So you must give it a name, and then you can check the progress with CDR stats check. And it gives you a kind of progress indicator. It is a bit perhaps unreliable. I wouldn't, but it does give you an idea of how it's doing. You can also try and seek out the sessions doing the select that I told you about. You can find those with -GSS, and you can maybe do some poking around to see what they're doing as well. But CDR stats check is quite useful. And you might want to monitor ER itself as well. So I think CDR view profile is the simplest way to do that. Where I work, we've managed to suck that into some graphing, so we actually graph a lot of the metrics that CDR view profile shows, and that makes it an awful lot easier to understand what's going on. It can be a bit tricky if you've just got the values on the screen. Sometimes CDR view profile can be a bit slow to run. So if that happens, CDR view profile command takes a long time. It's probably because you've got a lot of ATS or RIS files. So it's a good idea to process those or remove them. So there are commands to process those if you want to do it, or you can just remove them if you don't want them, you can just delete them. Another thing I'd just like to mention is CDR sync. So if you look in the manual, and this did cause me a bit of confusion for quite some time, there were two ways to sync two tables together. And I use the word sync there. So there's CDR sync and there's CDR check with the repair option. Now, these effectively achieve the same thing, but they are quite different. So I've already explained how CDR check works. CDR sync works quite differently. it creates a new shadow replicate and attempts to copy all the data across into that shadow replicate before switching it with the existing replicate. I believe that's how it works. I don't recommend this. For large tables, it does have a few issues. One thing is that it has a number of stages, and as it runs over a long time, as it changes what it's doing, it can dramatically change the profile of the load it's putting on your server. I've already mentioned about CDR valve threads earlier. If you've got a large number of valve threads, you could end up with very high CPU use on your server very suddenly. But CDR sync doesn't really require you to preload the table. You can just sync a replicate from empty. So while that tool is there, if you do see it, I do not recommend it for this particular operation. We're doing a large synchronization of a source and a target. It's better to use CDR check, and with the proviso that CDR check needs the source and the target to be quite close together. Otherwise, it will take a very long time. So when you're finished, so finished means that you've got two tables. They have the same logical schema. Actually, they don't have to have the same logical schema. You might want to add an extra column or do some change, but they're how you want them, with the correct indexes on as well. You then want to switch them in. So these are the kind of things you need to do. Stop the replicate, possibly delete the replicate as well, and then drop foreign keys, rename constraints and indexes, rename the actual table, drop and recreate any triggers. And you also want to make sure that all foreign keys referencing that table are dealt with as well. So provided here some SQL that you can use to find them, and you'll need to write SQL to drop those foreign keys, because they'll be referenced in the old table, and make them reference the new version of the table. Okay, I think that I'm finished, and I think I've said everything I want to say. So hopefully you've had a chance to ask questions during the chat, but I might stay around on Thursday a bit longer to answer any questions you may still have. Thank you very much. I'd just like to add that I do have a blog, which is informixdba.wordpress.com. There will be a blog about this subject arriving soon. It's currently in draft. It's sort of 70 to 80% finished, so you should see that out there soon.
That's perfect.